Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stay until the end of the video where I have two bonus problems for you guys to try and solve after I teach you guys how to solve this one. Alright, so we have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 2. Now the first thing I'm going to do is factor out 4 to the power of x. So now I have 4 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 2. Now I'm going to simplify what's in the parentheses. So I have 4 to the power of x times 4 is equal to 2. Now I'm going to divide both sides by 4. So then these two will cancel out. Now I'll be left with 4 to the power of x is equal to 2 over 4. 2 over 4, this here simplifies to 1/2. So I have 4 to the power of x is equal to 1/2. Now, if I have something in the form 1 over a, this is the same thing as a to the power of negative 1. Or let's say I have 1 over a to the power of n, this would be the same thing as a to the power of negative n. So 1 over 2, this is the same thing as 2 to the power of negative 1. Now 4, this is equal to 2 squared, so now if I replace 2 squared in for 4, I get 2 squared to the power of x is equal to 2 to the power of negative 1. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x, this will equal 2 to the power of 2 times x, which is simply 2x, and this equals 2 to the power of negative 1. Now if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2x is equal to negative 1. I can divide both sides by 2, and I have x is equal to negative 1/2. Now, another method of solving this is, remember, we started with 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 2. So I'll first factor out 4 to the power of x. So now I have 4 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 2. Simplifies from the parentheses, so I get 4 to the power of x times 4 is equal to 2. Now, instead of dividing both sides by 4, 4 is the same thing as 4 to the power of 1. And if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 4 to the power of x times 4 to the power of 1, that would equal 4 to the power of x plus 1, so equal to 2. Now 4, this is the same thing as 2 squared, so I have 2 squared to the power of x plus 1 is equal to 2. This would equal 2 to the power of 2 times x plus 1 is equal to 2. So I distribute the 2 and I get 2 to the power of 2x plus 2 is equal to 2. 2 is the same thing as 2 to the power of 1, so I get 2x plus 2 is equal to 1. I subtract 2 on both sides, so I get 2x is equal to negative 1. Now if I divide 2 on both sides, I get x is equal to negative 1/2. So as you can see, there were two different methods, but I got the same answer on both of them. Now to check my work, my original equation was 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 2. X is equal to negative 1/2. So now I have 4 to the power of negative 1/2 plus 4 to the power of negative 1/2 plus 4 to the power of negative 1/2 plus 4 to the power of negative 1/2 is equal to 2. Now, this is the same thing as 1 over 4 to the power of 1/2 plus 1 over 4 to the power of 1/2 plus 1 over 4 to the power of 1/2 plus 1 over 4 to the power of 1/2 is equal to 2. 4 to the power of 1/2 is the same thing as the square root of 4, which is 2, so I have 1/2 plus 1/2 plus 1/2 plus 1/2 is equal to 2. 1/2 plus 1/2 is 1, so I have 1 plus, again, 1/2 plus 1/2 is 1 is equal to 2, and 2 is equal to 2, and because this is right, our solution is right. Now it's time for the first bonus problem. Let's get started. What I'm first going to do is I'm going to factor out 5 to the power of x from the left-hand side. So now I have 5 to the power of x times, now 5 to the power of x divided by 5 to the power of x is 1. So now I have 1 plus, again, same thing, 1 plus 1 plus 1 plus, finally, 1. This is equal to 1. Now, I'm going to simplify what's in the parentheses. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 1 is 5. So I have 5 to the power of x times 5 is equal to 1. Now, 5 to the power of x times 5 is equal to 1. Well, 5, this is the same thing as 5 to the power of 1. So I have 5 to the power of x times 5 to the power of 1 is equal to 1. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So in this case, a is equal to 5, m is equal to x, and n is equal to 1. So now I have 5 to the power of m plus n. So x plus 1 is equal to 1. Now a, let's say I have a number a to the power of 0 is equal to 1. So a to the power, any number to the power of 0 would equal 1 besides 0. So I can rewrite 1 as 5 to the power of 0. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, a is equal to 5, m is equal to x plus 1, and n is equal to 0. So this means that x plus 1 is equal to 0. Now we have a simple equation. All I have to do is subtract 1 on both sides, and I get x is equal to negative 1. So this is my answer. Now, another way of doing this problem is I had 5 to the power of x plus 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 5 to the power of x is equal to 1. So again, I'm going to start by factoring out 5 to the power of x. So now I have 5 to the power of x times 1 plus 1 plus 1 plus 1 plus 1. This is equal to 1. Then I would simplify what's in the parentheses, so I get 5 to the power of x times 5 is equal to 1. Now, however, instead of multiplying these two, what I'm going to do is I'm going to divide both sides by 5. So then these two will cancel out, and I will be left with 5 to the power of x is equal to 1 over 5. Now, 1 over 5 here, well, 1, let's say we have 1 over a, this is the same thing as a to the power of negative 1. Or let's say we have 1 to the power 1 over a to the power of n, this would equal a to the power of negative n. So in this case, this is 5 to the power of 1, so this would equal 5 to the power of 1 over 5 is the same thing as 5 to the power of negative 1. So now I have 5 to the power of x is equal to 5 to the power of negative 1. And now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So now I have x is equal to negative 1. So these are two different methods, and I got the same answer in both of them. So now let's go ahead and check if this is right. So now I have 5 to the power of x plus 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 5 to the power of x is equal to 1, and x is equal to negative 1. So now I have 5 to the power of negative 1 plus 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 5 to the power of negative 1. Now this is equal to 1. Now remember, if I have something in the form a to the power of negative n, this is equal to 1 over a to the power of n. So 5 to the power of negative 1 would equal 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 is equal to 1. 1 over 5 plus 1 over 5 is 2 over 5. 2 over 5 plus 1 over 5 is 3 over 5. 3 over 5 plus 1 over 5 is 4 over 5. And 4 over 5 plus 1 over 5 is 5 over 5. So I have 5 over 5 is equal to 1. 5 over 5 is the same thing as 1 because any number divided by itself is 1. So I have 1 equals 1. And because this is right, our solution is right. Now it's time for the bonus problem. So I have 2 to the power of 40 plus 2 to the power of 40 plus 2 to the power of 40 plus 2 to the power of 40. And now I have 4 answer choices. So my first answer choice A is 2 to the power of 160. Now B here this is 8 to the power of 40. C, this is 2 to the power of 42. And D is 2 to the power of 21. Now, how people get A first off is what they do is they keep the base the same and they simply add the exponents. So they do 2 to the power of 40 plus 40 plus 40 plus 40. This is equal to 40 plus 40 is 80, 80 plus 40 is 120, and 120 plus 40 is 160. So they get 2 to the power of 160. And this method is actually wrong. You cannot add exponents like that. So now for B, we have 8 to the power of 40. And how people get this is they keep the exponents the same and they simply just add the bases. So they do 2 plus 2 plus 2 plus 2, and then they just do to the power of 40. Now 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, so they get 8 to the power of 40. However, this is also wrong. You can't add exponents like that. Now to get 2 to the power of 42, what they do is they first factor out 2 to the power of 40 from this. So now I have 2 to the power of 40 times 1 plus 1 plus 1 plus 1. Now 1 plus 1 plus 1 plus 1 is 4. So now I have 2 to the power of 40 times 4. And 4 here, this is the same thing as 2 squared. So now I have 2 to the power of 40 times 2 squared. And if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 to the power of 40 times 2 squared, that is going to equal 2 to the power of 40 plus 2. And this is equal to 2 to the power of 42. So this is actually the right method. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 6 to the power of x is equal to 9. Now what I'm first going to do is I'm going to take the log of both sides. So we have log of 6 to the power of x is equal to log 9. Now, if we have a logarithm in the form log a to the power of b, an important property of logarithms, also known as the power property, states that we can actually move this exponent to the front of the logarithm. So this would be equal to b times log a. So now I'm going to do the same exact thing to log 6 to the power of x. Now we can think of 6 as a and x as b. So I'm going to rewrite this by moving the x to the front of the logarithm. So now this would equal x times log 6 is equal to log 9. Now to isolate x, I'm going to divide both sides by log 6 so that we can move log 6 to the other side. So now we have x times log 6 divided by log 6 is equal to log 9 divided by log 6. Now for our left hand side, these two cancel out and we simply have x is equal to log 9 divided by log 6. However, if we have a logarithm in the form log a over log b, this is also equal to log base b of a. So we can think of 9 as A and 6 as B, meaning x would equal log base 6 of 9. So this is our answer.